Okay guys, in this video I want to continue where we left off, and I want to work on moving the player, which has to be done in script. Remember, in this class you got to write all your own code. I know there's probably some default scripts come with Unity that might help you with this, but not in my class. So here we go. Player paddle. It needs a script. And I'm just going to, under add component, hit new script. We have a C# script. I'll call this the player controller. This is a nice way to both create a script and have it attached to the game object. Puts everything in the assets folder, which we could later organize. This project is small enough I'm not going to bother, but anything of any kind of real scope you would probably want to organize your assets folder. Double click on this guy and my Mac friendly computer will bring up MonoDevelop. And we get a default script. And let me just do some window organization here. And the default script is a class that extends mono behavior, and it's got these very special methods that do very special stuff at very special times. Let's understand a little bit about what's going on here. I mean, now we have a player paddle. It has a transform component. So this is a game object. We call the player paddle a game object. And it's got a transform component, a cube component. It's got all these components, right? And then it also has this new component called a player controller. And the player controller's job is to move the player up and down based on the user's input, And we want to do that inside the update method. The update method is called once per frame. That's roughly 60 times per second, right? If things are running smoothly, which they should for Pong. Okay, next up, let's find out what the current paddle's position is. Simple enough. It is located under the transform component under the position property. That's the code access of this line right here. So position is a vector 3. It's got 3 separate properties, x, y, and z. And right now that paddle is at 600. Okay. Let's find out where the user is on his analog controller. We always pretend basically that we're using like an Xbox controller and the left thumb is on this standard analog stick that moves up and down. And it also moves left and right, but I want the vertical part of that analog controller. I'm going to call that V, and then I'm going to go get it, and it's actually just called the vertical axis in Unity. All this is configurable via the input manager, which you can find in the menus. But if you do it this way, then the player gets to reconfigure stuff if he has different controls or whatever. All right, so that's V. And if V is 1, the player's pushed the controller all the way to the top, and then if V is -1, it's all the way at the bottom, and if V is somewhere in between, he's somewhere between those two. What we want is the paddle to move up and down. If V is 1, we want the paddle to be moving up as fast as it can. And if V is all the way down, -1, we want the paddle to be moving down as fast as it can. That means we have to kind of give the paddle some maximum speed. I'm going to call that player speed, and we're going to start off at 10. And here we go. Let's change the Y value of the position. We're just moving the paddle up and down. So position.y plus equals V times player speed. And this is purposefully wrong. I'm going to show you what happens when we do this. Wait until we've compiled. When I press up in my game, assuming I coded everything right, things should have gone up. Hold on 1 second. Oh yeah, one more thing. We've got this temporary vector that we modified, but we've got to update the original vector, which is pretty easy at the very end of our update method. Why do I create a temporary vector? Well, one is writing POS is a lot easier than writing transform.position every time, but 2, you cannot modify an individual component like Y of the original position vector. You have to create a temporary copy and modify it. Okay, here we go. Demonstration of why this is broken. Play. Press up, and my paddle went like 7,000 miles high. Look at it. I mean, it sails right past the screen. It's ridiculously fast. Why is that? That's because I didn't take into account my frame rate clock. I'm running at 60 times per second. So if I tell it to move 10, every time this method is called, it's going to move 6,000 times in a second. That's way too much. We want it to move 10 units per second. And the key to that is delta time. Time.delta time represents how long since the last frame has been called. If it's running at 1/60th of a second, this value is basically 1 divided by 60, which slows the whole thing down and lets the paddle move at a pretty good rate, 10 units per second. By the way, W and S, or the up and down arrows, are mapped to mimic the analog stick. And you can see they really do mimic the stick with a little bit of momentum so that they smoothly change between 1 and -1. All right, great. Happy with that. Only problem, the paddle seems to go right through the wall. That is no bueno. We could make the paddle collide into the wall and force collision and stuff like that, but there is something really easy here, and that is just write an if statement. And we say, hey, if the position is too high, then don't move it. Let's see. How high would that have to be? If I move this thing, well, don't change the scale. Move the thing. How do you move again? Nope. You press this button. Yeah, here we go. Move this thing up. You guys see this value here? Looks like he's right at the top at 3.5. We could have also done the math on that, but who wants to do math? So let's put his initial position back to 0, make sure the scaling's all set, didn't mess anything up. Basically, we're saying, hey, if you are greater than 3.5 F, the float, we always use floats here, then cap it. And if we use an else if here, if position.y is less than -3.5 F, then cap it at 3.5. And here's the beauty of that, is that these little if statements are going to very smoothly let my paddle stop at the very top and very bottom. Beautiful. And it's got, again, a good feel to it. By the way, for those of you who want slicker than if statements, look up mathf.clamp. A very nice way to do this. Okay, so that ends player movement. See you in the next video.